So if you have an account, you just open a new tab in your Google, in your Chrome, then just start coding code.etengine.google.com and just press enter so to open the interface for you. So this is the interface for the Google Earth Engine. You have the tab for the script, you have the tab for the docs, you have the asset tab, you have the project name. So let's name our project. We'll name it when we start the coding. We have the run, we have the reset, you have the apps, have the inspector, you have the console, you have the tax. The tax is an area where, let's say, after you've done with your project, you want to export your work. You see the work being exported to that place. So this one project I did, and this I exported it. So this is the work, and the console is all the code you write. You will see the result being executed here. We have the inspector. Inspector help you to know what's going on, the number of pixels, the coordinates of the feature you select. So the reset also help you to reset the code. The apps helps you to create new apps, and the get link help you to generate a link for this IDE and send it, or the code or the project you're working on, and send it to a friend to also go through it. And this asset portion is where you upload your shape files in a form of either TIFF or GeoTIFF shape files and also CSV. Then the docs are JavaScript API that guides you in your coding, and the script is where your projects are being saved. Okay, so there's a new blank area we will be coding for our project. Okay, so let's go on with our new project. So now I'm going to take you through some simple syntaxes or coding with JavaScript. So before that, let's do some comments here. So in JavaScript, if you want to issue a comment, you use the double slash to issue a comment, meaning that all these codes will be written there, or the returns will be written there, will not be executed by this IDE. So okay, so JavaScript basics. Okay, so you're going to look at strings first. So strings is something like they are something like a test, a test that are being used in coding. Okay, so in JavaScript, if you want to define or print a text, you can use console.log, or in this environment, you can use print to print a text. So it has been a norm that whenever we are starting a project or a programming language, we use the simple string hello world. So let's print that. So console.log, then we type in your text, and there has to be in either double quotation marks or single quotation marks. Okay, so hello world. Okay, so you can see this small exclamation mark. Sometimes it look like an exclamation, meaning that you have to end it with a semicolon. In JavaScript, whenever we write a code, we end it with a semicolon. Then we just run it. You can see the console has turned green, meaning that there's some result there. When I click on it, you see it has been printed here. You can also use the print function. So print has to be here. Okay, so hello world. Okay, so I end with semicolon and I run it. So you can see here there's the function hello world. Okay, so this is how we execute a string. This is how we execute a string. So you can also use a double column and it will still give you the same result. So let's say console.log. So double column, then how are you? How are you? So if I execute this to give me a result of how are you, so I'm print the same thing. Okay. So let's go to numbers, printing numbers. Okay, so numbers. So print equals to number 67. Okay, so when I run this one, so 67. So you can also write console, okay, console.log. Then put in a variable or the number. For numbers, we don't put them in quotation marks. We just write them. So we run. Okay, so this is the number. If you put them in a quotation mark, meaning that you want to refer them as a string. That's when we do that. So we are going to look at concatenation. So concatenation is you're trying to combine or join strings and numbers together. So this is concatenation. You're trying to join strings and numbers together. So let's say I am 13 years old. So I'll just write print. So I am I am 13. So I'll just add plus 13. So I just end it with semicolon. The one I write it. So you can see I am 13 is being written here. So we have joined a string to a number. You can also print this one. Okay, so print. Uh, okay. Okay, cool. Yes. So plus 16 plus yes old. So Kogu is 16 years old. Okay. Kogu is 16 years old. Okay. So this is for strings and numbers. We're going to look at variables. Variables. So variables are something like containers that store or they keep either a string or numbers, so that they store other codes. There's something like a container which they store some code inside. So for you to define a variable in JavaScript, you have two ways: either to use the let or to use the var. So for this IDE, the one it support is the var. So if you want to define any variable, how to say var Then we put the name of the variable here. Okay. So say that the name of the variable is, let's say, name, then equals to, so the name is, let's say, Kofi, and this one is a string. So I have to put this one in a string. So I put this one in the string. Then I end my code. So this one, when you run this one, nothing will show because this one is a variable. We just assign the name to Kofi. So the next one is, the next variable you're going to define is a variable name two equals to actual. So define another variable. So this one is the first variable, second variable. Okay. So now if you want to print it, if you want to print name 2, you can just say print. Then I have to insert the name of this one. So name 2. So I want to print this one. So when I run, to give me the name of what this name 2. So that's how variables works. That's how variables works. So there's a little I want you to know about. I want you to know what JavaScript. There are more into it, so you can just read on it. So I'm going to delete this one, then go back to our main work. So we are going to learn how we can. So you're going to continue with the classification. So we first have to add in our study area. So what we'll do is I'll just go to assets. So before you have to make sure that you have load the shapefiles of your study area using this link and the assets area. So after loading it, just come here. You see the, or you can just refresh the system and you see that the study area you uploaded is here. Then just click on this arrow, import into script. So this is study area. Now you can change it to give it, let's say, area of interest. Just my area of interest. So meaning I have to make it visible now on the map here so that I can see and work on it. So what I will do is that I will add it as a layer. So I will add it as a layer. So I'll use this function map dot add layer, then bracket, then I add UI, then I'll just specify some zoom extent. So and center the map. So now what I want to do is I want to make it in such a way that when I run the software or when I run the IDE, it will bring me my study area wherever it is. So I'll just use this function map dot center object. So bring the study area to the center of the map as some zoom extent I'll give it. So center object. So I'll specify my area. Then the zoom extent, let me give it 10. End my command. Can now run it. Okay. So the map is yes 1p. Okay. So you can see that has bring me my steady area. So this is my steady area. So the next thing for us to do is to bring in our satellite image. Bring in our satellite image. So you can just go here, the search option, then go to browse data log. So you see all these ones are satellite images that we can use for our classification. They are all satellite images. If you want to do cropland classification, if you want to use the physical data classification, land cover description, terrain. So the data you're going to use Sentinel satellite data. So just click on Sentinel. If you want to use Landsat, you can just click on Landsat. If you want to use Moody's, you can just use Moody's. There are a lot on this one, so you can just use the YouTube and watch some of the videos about these things, and it will boost your understanding on it. Or if you say, I will be sending you some document that will guide you to help you understand these ones. So Sentinel, you're going to use Sentinel 2. You're going to use the top of atmosphere. Okay. So when you open that link, this is the information about the satellite image we're going to use. So this is the data set availability. So this one, it's available from 2015 to 2023, and this is the data provider, and this is the Earth Engine link to get access to this data, and this is the band. This is the bands. So you have band 1. So these are the bands of the satellite. Then the image properties, when I click here, these are the image properties. Then this is the terms. So this one can also help you to correct the mask on the image. So able to correct the mask on the image. So if there are some clouds on the image, when they come to the terms of use, this one will help you to correct the image. You can see there are comments on the said function to mask clouds using the Sentinel-2 QR band. So this is the function. So all these are codes that can help you to remove the clouds from the image. So these are sample codes that will help you. Okay. So we're doing the same in our work. So what you have to do first is that you have to give a variable to represent your image. So let's say var sentinel 2 equals to, so meaning that I'll specify or define a new variable called sentinel 2. So what I'll do is I'll just copy this link, then paste here. So this is the sentinel image I'm going to use to my work. So I'm going to use this sentinel image to do my work. So now I'm going to filter it. So filtering means that you see we don't need all the satellites. This one is for all the world. So you're going to filter it to cover only our steady area, and we're not going to use all the years. You're going to filter it to get the years you want to work on it. Okay, so first for filtering, I'm going to do it. We're going to filter it to get the image only around our boundary. So just use filter bounds. Now we specify our area into it. Specify our area into it. Okay. So now we specify our, so that will be, so that will be our, so this one now the name of our Landsat now, or the Sentinel now, is Sentinel 2. So the variable you have defined dot filter bounds of your actual steady area. Okay, so that's how we do it. Then now you're going to filter it with the date. So you're going to filter it with the date. So yes, go by filter date and specify the date range. So you specify the date range. To specify the date range, that one will be 2002, the month of, so they have to be in the single quotation mark, 2022 January, the month of January, then the first day, then that's the range you want to specify. Then 2023, then the month of January, the first year. So this is the date filtering we are using to filter our image. So we need an image from 2022 month of January, the first day, to 2023, the month of January. So that's what we need. Then after that, we want to remove the clouds. You want to remove, if there are some clouds on the image, you want to remove it and get clouds with only small, or get images with only small clouds on it. So you can go, when you go here, you go to the terms use, you can see that this one we are trying to remove the clouds from it. So this is the function to remove the clouds. So that's what we're trying to say, that you should remove all the images and get image of 20%, only 30%, so less than 20%. So you can see this dot lt here means that less than 20% clouds. So that's what we are also going to use. We are going to use less than 1% cloud. So this is the script. So this is the script. I'll just come here. So the function is filter to brackets ee.filter dot less than, say, cloudy pixel percentage. This cloudy pixel percentage is from the image properties. So when you come here, we see cloudy image percentage, and then look at the description. It said the granular specific cloudy pixel taken from the original metadata. So we use this metadata to help us get the images which contain the clouds, then we can sort or filter to get the image we need. Okay, so we are done with this one. Then so the next thing you're going to do is that you're going to tell you want to write an algorithm for it to arrange all the images and take the median image. The median image. So you can just write dot median, so dot median, then open the function. So this one will take the median image. Then now the next thing to do is that we're going to clip the image into our steady boundary. So yes, right, dot clip, then specify our boundary, that is OAI. Okay, so now allow for us to display our image. Okay, so let's run it and see what will happen. Okay, it's covering the whole place. I think this is the mistake. So this one has to come here. So let's run it again. Want it to cover only our city area. Also, when you come here, you can see that it's loading here. So all the layers we've added, we create a new layer here. Okay. So you create a new layer. If you want to name the layers, you can just come here and just push comma, then specify the name. So let's say the first layer is steady area. A steady area. Let me run it and see what will happen. Okay. Okay. Okay, so we added to the second one. So let's run it again. Okay. So we'll come here. So this one is the steady area. This one is our blessed image. So when I click, when you hover on it, you see that small settings here. Okay. So there's the small settings here. So when I go to layers, I click on this one. So these are the bands here. So for you to see the natural colors, you have to change the band to fit that. So you can just search, let's say, band combination for Sentinel 2. So band combination for Sentinel 2. Band combination for Sentinel 2. So they're saying that if you want to see the natural color of the area, you have to arrange it in this way. Band 4, band 3, band 2. If you want to see the color infrared, you have to arrange it band 8, band 4, band 3. If you want to see the short wave infrared, band 12, band 8, band 4. If you want to see the agriculture section, band 11, 8. So that's how you're going to. So now you want to see the natural color. So you have to arrange it in band 4, band 3, and band 2. So you go to our code, you go to this place. So it will be band 4, band 3, then band 2. So this one will help us to see our natural color. So how to, when it comes to the custom, how to go to stretch to 100%. After that, just click on apply. Okay. So you can see that now you are seeing the natural color of the area. You can see the natural color of the area. So you can see the natural color of the area. So you can just zoom in small to see what is going on. See what is going on. Okay, so this is the natural color of the area. So meaning that this is the parameter which is giving us the visualization. So what we do have to do is they have to import this parameter. So just go here and click on import. So you can say it will automatically be added to this one. So you can see that var image visualization parameter, that is, so we are using band 4, band 3, and band 2. Okay, so when you open it, so these are the bands, this is the opacity, and there is the maximum and the minimum values. Okay, so after importing, then close. Now we want to add these parameters into this one so that whenever you run, you just give us the natural color, but not the satellite image before the viewer. So just go here, then we copy this parameters values, then we come to this place, then we want to give it a name. Let's say natural color. Okay, so let's run it and see. You can see the natural color is appearing, and let's check the layers. You can see that the name I gave it to it is showing here. That is the natural color. Okay, so now, okay, so the next thing you're going to do is that we're going to select some bands, we want to use to make our classification. So you're going to select band 1, band 2, band 3, band 4, band 5, and band 7. By ignoring the band 6, band 6 is a thermal band, so we're not going to use that one. So first, so what I will have to do is I have to define my variable. So variable I'll give it a name. It's a bands. So I'm going to list them. This one is a list. So for a list, you have to use the square brackets and the bands. Yes, so I have to check the name of the bands. So when you go to the image, you go to the bands because these are the name of the bands. Have B1, B2, B3. So these names represent the individual bands in this satellite image. So just list them. So B1 for band 1, B2 for band 2, B3 for band 3, B4 for band 4, B5, then B7. So this is the bands we are interested in. These are the bands we are interested in. So now you're going to tell our image now to select only that band. So I'll create a new variable var. So you're going to give it a name. Let's say input. So input will be, so I'm going to say that my sentinel2. So this is the what I'm working on right now. My sentinel2 dot, if you select only the bands I have defined. So I define it by using the name band. So I'll just give it that name bands. So this is what I'm going to use to, or these are the bands I'm going to use. Okay, so now I've defined or I've selected only these bands, band 1 up to band 7, by ignoring the shake. These are the bands I'm going to work on. So now I can just inspect my image and see what's going on. So you can just go to the inspect. So when you come, that's how the symbol will look like. So just click on it. You see that generated some info for us. So this one is the longitude and latitude of the point or where I clicked. When it comes to the pixel, to give you the natural color. And you see for the bands, we haven't bands up to 12, and there are other bands. So each band and its band value. So these are the bands. So the one which are having the larger pixels, larger number of pixels, and the one that are having the smaller number of pixels. So when you look at the graph, you will see, and even if you hover on it, you see the band value. Okay. So all these things are the interpretations of the bands. So yeah, when you come down here, they are all interpretations of the bands. We have band 1 up to band 16. Okay. So now, so these are just the inspection of the area. So now I want to select only this 6 bands from all the bands. So you see I've defined the variable here. So what I'll do is that I'll just select that. So let me print this um, bands and see whether they are working. So I'll just print then input, because these selected bands are being stored at the input. So I'll just run it and see the result I'll get. Okay, you can see the image is containing 6 bands now. So I'm just going to use, so band 1, band 2, band 3, band 4, band 5, then band 7. So these are the bands I'm going. These are the ones I specified. So these are the ones I'm going to use. So when you open each one to you see the other informations about the band. Okay. So now I'm going to create my training samples. My training we're going to do supervised classification. So I have to generate my training samples. So what I'll do is that let me view to the area and see what's going on. So let me zoom in. Let me zoom in to see what is going on. Okay. So let me zoom in small. Okay. So this is Takwa and Shaim, the Takwa and Shaim district. So now I have to create my training sample. So before I can create your training samples, you have to create new feature collections. So when you come here, you're going to use you can either use the add place marker or the polygon or the square to do so. So you just click on this one, then it will give you the name. So when I click on this so small settings, then give it a name. So let's say the first one is mining area. So MN. So mining areas. Then come to the import geometry, go to feature collection. Then now you add property. So this one you give it a class name. So they will all be under the class of class. Then the value we're going to do them individually. So for mining areas, I'll give it a value of 0. Then I'll give it a color and so let's say I want to use blue. Then okay. So I can now start digitizing my mining areas. So just click. You'll just be clicking at where you think these areas are mining areas. Okay. Okay, so because of demonstration sake, I'll just end up to this one, but you can click more and scroll down and click more so that you can get a good qualification process. Okay, so now let's say I'm done with my minor areas. So what I'll do is that I'll just go to this place again, then choose a new layer, then click on this one. Now I'm going to do for vegetation. So vegetation, then import the feature collection. then add it. So the name is class, the property name is class, then the value I'll add 1. Now choose my color. Okay, it's okay. Vegetation, so I'll say these areas are for vegetation. These areas are vegetation. Okay, so let's say I'm done with my vegetation. The next one, I'll go to new layer, go here, select with, let's say, the urban areas, urban areas, or as a settlement. I'll give it a feature collection. Then the property name class, then give it a value of 2. Then specify my color. Okay. Then so these areas are there. These areas are the areas. Settlement areas. Okay. So you can see that all the classification I've made have appeared here. So you can see. So for money areas, I created 53 samples. For vegetation, I created 34 samples. Settlement, I created 4 samples. So all these things. So once you click them, it automatically generates the algorithms for you to automatically generate the algorithms for you. So these are my classifications. So it automatically generate the algorithms for you. So now the next thing left for us is that now we've created all our training samples. So now you have to match all the training samples to be one. So what you're going to do is that just go here. So just create a new variable var, then let's say training, give it a name, training samples. Unit of which equals 2. We're going to merge all the training samples. So the first one is so many areas. Let's copy that one and count that this place. So dot merge. Do you want to merge it with what? So you put in we want to merge it with the classification the vegetation, then just put the vegetation inside, then dot merge. You want to merge it to the settlement. Okay, so now we have merged all the vegetations, the mining areas. So I've merged everything. So now let's print the training samples and see what the result we get. So print training samples. Then let's run it and see the result we will get. Okay, so you can see this is the result. So meaning that we added, or we able to generate samples of 122 elements. So all our other information have been provided here. So these are the 121 elements. So that started from zero. Okay, now this is the result. Now you've seen that we've combined all the training samples. So let's check something at this place. So we see when we go to columns, now when we go to feature list, we go to the feature, then we go to the property. You can see we have only one class here. We have only one class here. So now we have to sort it. We have to sort it to see that if, let's say, we open the first feature we have to get the band one of the first feature, the band two of the second, the first feature, the band three of the first feature. So that we are going to arrange everything so that it will take, every feature will have its own bands. So that's what you're going to do now. So we just go. Let me have. I think I have a script here already. So let me just paste it here and do some small things so that we go. So now I'll create a variable named training. Then this one, the name I gave you to my test image is Sentinel. So I'll just ignore the image and put the name here, Sentinel. So the Sentinel dot select bands. So these are the bands. Then dot sample regions. So this sample regions will sample all the feature lists and arrange them to give you the each feature and its bands. So the collection here is our training sample. So we place this one with the training sample here. Then the property is this one. You see, the feature class, we give it a property of what? Class. So I have to make sure that if the same inflated here, then we give it a scale. Okay. So let's run this one and see the results to give us. It will take some small time, so let's have to pause and wait for it. Okay, it has finished running, but no results shown because we didn't print any results. So now let's print our training. So print, the name we give it is training. So let's print our training. Then let's run it. Okay, so that's finished running. So this is the result. Let's check and see. So you can see when it comes to properties, you can see everything that be sorted out. So you can see band 1, band 2, band 3, band 4. Okay, so let's check the feature. So when you go to the first feature, when you go to properties, you can see that sorted the band 1, band 2, band 3 to band 7, and each one is having its band value. When it comes to feature 2, the properties, you see, so this is what we wanted to achieve now. Everything has been achieved successfully. Okay, so it left for us to classify uh, our image. So when you go to docs, you go to classifier. So all these are algorithms that can help you to classify your image. You have the smart random forest, you have the smart live bias, you have the smart gradient trees, you have the smart cut. So today we're going to use the smart cut. So I have algorithm, I just paste. So now this is the algorithm. So you have to define your variable. So var classifier. The name is classifier. Then you just have to execute the search engine smart cat classifier. So the name is ee.classifier.smart. Then you put in these parameters. So smart.train. Then you put in the parameters. So the features is the training we've created here, and the class property as being defined here is class. Then the input parameters is the what, the bands. So these are the three parameters we're going to depend on to do our classification. So these are the three parameters we're going to use to define our classification. So this is our algorithm to classify the image. So this is the variable name. This is the algorithm, one of the algorithms that's being used for classification. So smart cat, I'll just define it. And these are the three parameters you're going to use: the features, the training, and the class of the bands. Then now define another variable called classified. Then we put in our image. So then does select, going to use the bands, then we just classify it. Then we create a new, or we add a new layer of the new classification we have done, and there's add the individual colors. Since we are going to deal with three classifications, from so meaning that the minimum value will be 0 and the maximum value will be 2. So from 0, 1, and 2, we have three classifications. So these are the colors. These are classifications. If you want to change the colors, you can just go here, click here. So any color you want, just click on it, and you see the color code will come. Just copy and paste, and just go and paste it at this place. Okay. So you can see that now our classification is being done successfully. So now you're done with the classification successfully. Okay. So after here, then you have to export your map. So here, you have to export your map. Okay. So I have the syntax here too. So okay, let me see. Okay. So thank you very much. So these are the process you can use to classify your image. So when it comes to layers, this is the classification. So let's try and inspect something here. So when I click on it, let's see what's here. Okay, you can see classification has also been added to it. Okay, thank you very much for your time. Thank you for watching. If you have any question, I just contact me. Then I think we will talk more about it. Thank you.